Hi, Algebra 2. These are the Lesson 5 homework answers right here. So you should have already watched the video for Lesson 5 and tried these homework problems. If you haven't tried them on your own, please try them first. And you don't have to watch the whole video, but if there's something you got wrong, you can fast forward it to that part. So number one is they want us to find the exact value of each of the following angles. So notice that I've drawn a little graph for each of them so I can sort of graph them. I can see what the reference angle is. I can see when it's positive and negative. Notice every single one I've written, all students take calc. You have to be aware of what quadrant you're in. So if your final answer is going to be positive or negative. So the first one, tangent of 315. So I draw 315 degrees, which leaves me in quadrant 4. The reference angle is going to be 45. I find that reference angle by doing 360 minus 315. The tangent of 45 is equal to 1. I'm in the fourth quadrant though, and tangent is negative in the fourth quadrant. The only thing that's positive in the fourth quadrant is cosine. That's what the C stands for. So the tangent of 315 is negative 1. Secant of negative 225. So remember, negative 225 is going to actually go clockwise. So the angle is going to wind up being right here in the second quadrant. The reference angle, 225 minus 180. My reference angle is 45. Secant is the inverse of cosine. So I find it easier just to find the cosine of 45 because I know that one right off the top of my head, or I could look in my little chart that I've memorized. The cosine of 45 is radical 2 over 2. I am in the second quadrant, and cosine is negative in the second quadrant, so secant would also be negative in the second quadrant. I'm doing secant though, so I do have to flip it. So this negative radical 2 over 2 gets flipped, and it's just negative 2 over radical 2. And then I just have to rationalize the denominator. So this is basically my answer, except I can't have a radical in the denominator. So I multiply the numerator and the denominator by radical 2. So I get negative 2 radical 2 for the numerator, and radical 2 times radical 2 in the denominator just equals 2. These 2's then can cancel, and my answer is just negative radical 2. For C, I'm going to change this to degrees because right now I have 5 pi over 3. The way I change that to degrees is I multiply by 180 over pi. So the pi's cancel. 3 goes into 180 60 times. 5 times 60 is 300. So this is actually sine of 300 degrees. Sine of 300 degrees would look like this. There's a little sketch. It's in the fourth quadrant. The reference angle is 60 degrees. I did 360 minus 300, so my reference angle is 60. The sine of 60 degrees, I have that memorized, is radical 3 over 2. I am in the fourth quadrant though, and sine is negative in the fourth quadrant, so it's going to be negative 3 over 2. So my original problem wanted me to find the sine of 5 pi over 3, and that answer is negative radical 3 over 2. Sine of 510, I have to do 510 minus 360. That's really just the sine of 150. That has a reference angle of 30. The sine of 30 is 1/2. I am in the second quadrant, and sine is positive in the second quadrant, so my answer is just 1/2. 2 is nice and easy because I have that memorized. The value of sine of 60. Sine of 60 is radical 3 over 2. And I drew my 30, 60, 90 triangle for you. So in case you didn't have it memorized, you can just do it out. The side across from the 30 is 1. The hypotenuse is 2. And the side across from the 60 is just 1 radical 3. And sine, of course, is opposite over hypotenuse, which is where I got the radical 3 over 2. But hopefully you guys have those memorized, or you can just look them up easily. 3, I want to write in exact form the cosine of 135 degrees. So cosine of 135 degrees, the sketch would look like this. It's in the second quadrant. It has a reference angle of 45. I did 180 minus 135. The reference angle is 45. Cosine of 45, I have that memorized, is radical 2 over 2. I am in the second quadrant though, and that's going to be negative. Okay, so it's kind of hard. What we used to do these back last year, and we'd do them in our calculator and we'd get decimal answers. I'm looking for the exact answers here, which is why it's important to understand all of these reference angles. and also the quadrants, whether they're positive or negative. 4 wants to know which of the following is not equal to the sine of 270. So I drew a little sketch right here. This point is 1, 0. This is 0, 1. This is negative 1, 0. This is 0, negative 1. Sine of 270, this point right here where my cursor is sine of 270. Sine is my y coordinate. So sine of 270 is negative 1. And then I have these highlighted, each of these. Cosine of 180 is right here in yellow. The cosine is the x coordinate, so cosine of 180 is negative 1. In green, I have negative cosine of 0. So cosine of 0 is right here. Cosine is the x coordinate. It's 1, but I want to negate this, so it's negative 1. Sine of 90, negative sine of 90, sorry, is in blue. 90 degrees is right here. The sine is the y coordinate. It's 1, but it's negative sine of 90, so it's negative 1. The only one that is not equal to negative 1 is sine of 360. I have in pink right here. Sine of 360 is the same thing as sine of 0, and sine is my y coordinate, sorry. Sine is my y coordinate, so that is equal to 0. And these you could do in the calculator also just to check, but it is important that we're understanding all of this and looking at it graphically. Number 5, the terminal ray of an angle drawn in standard position passes through the point 0.28, comma, negative 0.96. So remember, whenever I have a point, my x-coordinate is my cosine and my y-coordinate is my sine. So they want to know which of the following represents the sine of the angle. So the sine of the angle is 0.96. I drew a picture for us also just so we can see it visually, what it looks like. All right, again, xy is the point, cosine is the x, sine is the y. This is the reason why cosine is the x and the sine is the y, because cosine is just going to be adjacent over hypotenuse, so it's 0.28 over 1, and sine is going to be opposite over hypotenuse, so it's 0.96 over 1. Number 6, I have the point negative 512 lies on the circle whose equation is x squared plus y squared equals 169. Which of the following would represent the cosine of the angle drawn in standard position whose terminal ray passes through point A? So I drew a picture right here. Negative 512 is going to be over here in the second quadrant because it's negative 5, positive 12. Okay, I did the Pythagorean theorem to find this missing hypotenuse of 13. So negative 5 squared plus 12 squared equals c squared. That's a Pythagorean triple, so you probably didn't even have to do it out, but it does come out to be 13. And then I want to find the cosine. Cosine is adjacent over hypotenuse. So here's my angle theta. Adjacent is negative 5, and my hypotenuse is 13, so it is choice 3. Which of the following values cannot be the sine of the angle? Think about the range of the y values on the unit circle. So the unit circle has a radius of 1. So the sine needs to be a point between 0 and 1. So sine will never ever be negative 3/2. Number 8, for an angle drawn in standard position, it's known that its cosine is negative. So I drew my little graph here with ASTC. All students take calc. Okay, so it is known that the cosine is negative. They're all positive in the first quadrant. Sine is positive in the second quadrant. That would make cosine negative. Tangent is positive in the third quadrant. That would make cosine negative. And in the fourth quadrant, cosine is positive. So I'm looking for where cosine is negative. That could possibly be the second quadrant or the third quadrant. And the sine is positive. Sine is the positive in the first quadrant and the second quadrant. So where do they overlap? They're overlapping in the second quadrant. So in the second quadrant, sine is positive and cosine is negative. I want to just sketch an angle of 10 pi over 9 in standard position. I'm going to change that to degrees. So 10 pi over 9, I multiply by 180 over pi to change that to degrees. The pi's cancel. 9 goes into 180 20 times, and 20 times 10 is 200. So 200 degrees would look just like this. I want to take 245 degrees and express it in radian measure. So that means I'm multiplying by pi over 180. So I'm going to get 245 pi over 180, and that can be simplified to 49 over 36. Okay, you can just divide 245 over 180 and get a decimal and then change that back to a fraction. Just don't forget that the pi is still with the number. And number 11, the terminal side of an angle in standard position passes through the point 25. So I drew a little sketch right here, 2 cant of theta. I need to find this missing side right here. So I do the Pythagorean theorem, 2 squared plus 5 squared equals x squared. 4 plus 25 equals x squared. X squared is 29, so this hypotenuse is radical 29. Now, cosecant is the inverse of sine. So I'm going to do the sine. The sine of theta is opposite over hypotenuse. And cosecant is the inverse, so it's actually hypotenuse over opposite. So it's radical 29 over 5. That's a 5 right there. I got cut off. Okay, and those are the answers for lesson 5 homework.